T4, T4 is here, T3 divided by R rho gamma minus 1 minus T1, T1 is T3 rho R gamma minus 1. Again divided it by T3 minus T2. What is T2 here? 1 by rho T3. Now, this can be further derived like this. Efficiency is 1 minus 1 by gamma. Now, from T3 is common, it can be written like this, rho R by gamma minus 1 minus 1 rho R by gamma minus 1 and divided by 1 minus 1 by gamma, which is further equal to 1 minus 1 by gamma. Again you take this term outside, R gamma minus 1, this is equal to rho 1 by rho divided by 1 minus. So, we can write it like this, 1 minus 1 by gamma divided by R gamma minus 1. So, this is rho gamma minus 1 and this is equal to rho gamma divided by rho 1 by rho divided by rho minus 1 rho. This is further equal to 1 minus 1 by gamma R gamma minus 1 and this is equal to rho gamma minus 1 divided by rho minus 1. This is your relation of air standard efficiency in case of diesel. Now, if the value, that is cutoff ratio, compression ratio, index of expansion is given, you can find out what should be the efficiency of the engine, that is diesel engine. You can also compare the efficiency with the petrol cycle by taking these terms and compare with the what is given in the Otto cycle. You can find out the efficiency difference in this case. Further is last cycle, that is dual cycle. We will move to the next cycle, dual cycle. Dual cycle is also a semi pressure constant pressure cycle, semi pressure limited cycle. In this cycle, if you draw a PV diagram on this, PV diagram on this, point 1, the compression process, heat is added and expansion, then heat is rejected. 1, 2, 3, 4 and 5. So, these processes 1 to 2 again compression process, adiabatic reversible compression process, 2 to 3 heat is added at constant volume, 3 to 4 heat is added at constant pressure, 4 to 5 expansion, isotropic expansion of the cycle, and 5 to 1 exhaust or heat is rejected. How the cycle completes. Now, in this case, you find out what is the work done. Heat supplied minus heat rejected. Now, what should be the heat supplied in this case is, heat is supplied at constant volume and constant pressure. CV T3 minus T2 plus CP T4 minus T3 minus heat rejected, that is at constant volume, CV T5 minus T1. Now, again I will write here the efficiency of the cycle. Efficiency is work done, that is CV T3 minus T2 plus CP T4 minus T3 minus CV T5 minus T1 divided by heat supplied. What is the heat supplied here? CV T3 minus T2 plus CP T4 minus T3. In dual cycle, the heat is added at constant volume and constant pressure. So, that is why it is also called limited pressure cycle, limited pressure cycle. So, it can be further derived 1 minus CV T5 minus T1 divided by CV T3 minus T2 plus CP T4 minus T3. Now, if you divide it by CV, you will get 1 minus T5 minus T1, T3 minus T2, CP divided by CV, that is gamma T4 minus T3. Now, again it can be further derived in the same way by taking the different processes, that is 1 to 2 process. 1 to 2 processes. In this case, T2 by T1, again the same thing, 1 to process V1 divided by V2 is gamma minus 1, that is R gamma minus 1. Now, second 2 to 3 process, 2-3 process, that is constant pressure process. Here we will define another term P3 divided by P2 is called alpha. This is explosion ratio, explosion ratio. So, we define 3 terms here, that is compression ratio, cutoff ratio, and third is explosion ratio. Cutoff ratio is rho, compression ratio is R. V1 divided by V2, V4 divided by V3. So, we can write it in the 2/3 process, that is constant pressure process. Apply the gas equation here. We will get here P3 V3 divided by T3, P2 V2 divided by T2. This is further equal to, as the volume remains constant here. So, we can write it P3 by P2 is nothing but T3 by T2. From the first question, T1 is equal to T2 by R gamma minus 1. This is our first question. Now, in this case, T2 is equal to P3 by P2 is alpha explosion ratio. We can write it T3 by alpha. If you put T2 in this equation, this is your second question. If you put in T1 equation, you will find out T1 is nothing but T3 alpha R gamma minus 1. Now, take next process. What is your next process is 3 to 4 process. In 3 to 4 process, it is a constant pressure process. Apply the gas equation P3 V3 divided by T3 equal to P4 V4 divided by T4. As the pressure is constant, we can write it T3 divided by T4 is V3 by V4. V3 by V4, as we know, V4 by V3, this is equal to 1 by rho, and T4 is nothing but rho T3. So, similarly, take the process 4 to 5. I will say the same thing is happen here, T5 by T4 is equal to V5 by V4 gamma minus 1, which is equal to R gamma minus 1. Put the value of T4 here, and get the value T5 in terms of rho T3 R gamma minus 1. Now, put these values in the efficiency equation. You can derivate what should be the value in terms of. Thank you very much.